Hello, everyone. Today, we'll be exploring one of Earth's most important layers, the lithosphere. This layer is crucial to understanding many geological processes, including the formation of continents, earthquakes, and even volcanic eruptions. Let's break down what the lithosphere is, how it works, and why it matters. The lithosphere is made up of two main layers, the crust and the upper mantle. Let's take a closer look at each. The crust is the outermost layer of Earth, much like the skin of an apple. It's composed of various types of rocks and is much thinner under the oceans, only about 5 to 10 kilometers thick, and thicker beneath the continents, ranging from about 30 to 100 kilometers thick. Just below the crust lies the upper mantle. This part of the mantle is still solid, but can bend slowly over time. It behaves like a very thick, slow-moving liquid due to the heat and pressure from deeper layers of the Earth. The lithosphere, Earth's outermost layer, is divided into large sections called tectonic plates. These plates are not stationary, they float on the asthenosphere, a softer semi-fluid layer beneath them. Due to the heat and pressure within the Earth, the plates move very slowly over time, driven by convection currents in the mantle. As these plates move, they interact with each other at their boundaries, leading to various geological events. For instance, earthquakes occur when plates grind past each other or collide. Volcanoes form when plates pull apart or one slides beneath another, allowing magma to rise to the surface. Mountain ranges are created when plates collide and push land upwards. The movement of these plates, known as plate tectonics, is a fundamental force in shaping Earth's surface. It not only creates landforms, but also drives the geological processes that affect the planet's environment. An earthquake occurs when tectonic plates grind past each other or collide. These movements cause sudden releases of energy, which shake the ground and can be felt across large areas. These sudden shifts in the Earth's crust can cause significant damage to buildings, infrastructure, and the environment. Earthquakes often trigger landslides, tsunamis, and other natural disasters, making them particularly dangerous, especially in densely populated regions. The severity of an earthquake is measured using the Richter scale, which is a logarithmic scale. This scale quantifies the energy released during the earthquake, with higher numbers indicating stronger earthquakes. For example, an earthquake with a magnitude of 5 on the Richter scale releases 10 times more energy than one with a magnitude of 4. Volcanoes are a fascinating result of Earth's dynamic processes. Here's how they form. Molten rock. When tectonic plates move apart, or one plate goes under another, heat from deep within the Earth causes rock to melt. This molten rock is called magma. It is formed under extreme pressure and heat deep within the Earth. Volcanic eruption. As magma rises toward the surface, it can erupt in different ways. Once it reaches the Earth's surface, it's called lava. Depending on the pressure and the type of eruption, the lava can either erupt violently or flow slowly. This process leads to the formation of volcanoes. The lava cools and solidifies, forming layers of volcanic rock over time. New land. Over time, repeated volcanic eruptions can create new land, including islands and mountain ranges. As the lava builds up on top of older layers, it can form new volcanic islands or even grow mountains. This process is continuous, with some of the most famous islands like Hawaii being formed in this way. Mountains are formed through the movement of tectonic plates. Here's how it happens. Plate collision. When two tectonic plates push against each other, the force from the collision causes the land to buckle and fold. This is similar to when you press two ends of a towel together and it forms folds. The land becomes compressed and starts to rise. Upward thrust. As the plates continue to push, the land is thrust upwards. Over millions of years, this constant force pushes the land higher and higher, eventually forming mountains. This process can take millions of years, but over time, significant mountain ranges are created. Mountain ranges. Some of the world's most famous mountain ranges, like the Himalayas, Andes, and Alps, were formed through this process. These mountain ranges are the result of intense collisions and continued thrusting of tectonic plates over a long period. The lithosphere plays a key role in supporting life on Earth through several important processes. Let's look at how it influences our environment. Erosion. The lithosphere is constantly shaped by the forces of erosion. Erosion occurs when elements like rain, wind, and ice break down rocks. Over time, this process shapes the landscape, creating valleys, rivers, and other landforms. Erosion also contributes to the formation of soil, which is essential for plant life. Soil formation. Soil is vital for plant growth and is a fundamental resource for supporting life on Earth. It forms when rocks break down due to weathering and erosion, combined with the addition of organic matter like decaying plants and animals, as well as minerals from the rocks. This soil then supports plant growth, which in turn supports the entire food chain. Water sources. The lithosphere also stores groundwater and provides sources of rivers, lakes, and oceans. Groundwater is vital for drinking water, agriculture, and ecosystems. The lithosphere's role in storing and supplying water makes it essential for sustaining life on Earth. The lithosphere is an important source of several natural resources that are vital for human life and industries. Let's explore some of the key resources it provides. Minerals. The lithosphere is a vast storehouse of valuable minerals. These minerals are crucial in a wide range of industries, from building materials like cement and steel to electronics used in devices like smartphones, computers, and batteries. Minerals are extracted through mining, which is one of the main ways we access these resources. Fossil fuels. Deep within the Earth's crust, ancient organic matter has undergone transformations over millions of years to form fossil fuels like oil, gas, and coal. These fuels are burned to produce energy for heating, electricity, and transportation. However, their extraction and use also raise environmental concerns due to their contribution to pollution and climate change. Water. The lithosphere also plays a role in storing groundwater. Water is stored in the pores and spaces within rocks and sediments. This groundwater is a critical source of fresh water for drinking, agriculture, and ecosystems, providing a significant part of the world's usable water supply. The lithosphere is a dynamic and vital layer of Earth, playing a crucial role in shaping our planet's surface. It is responsible for many of the processes that we see, such as the formation of mountains, ocean floors, and the occurrence of natural disasters like earthquakes and volcanic eruptions. It also provides essential resources, including minerals, fossil fuels, and water, all of which are key to supporting life on Earth and driving human activity. Studying the lithosphere helps us understand the history of our planet and how it continues to evolve. By examining its movements, interactions, and impact on the surface, we gain valuable insight into the forces that have shaped Earth and will continue to shape it in the future.